Have you ever wondered about the processes your water goes through before it ever reaches your faucet? Today, the CWSA will take you through the elaborate process of how your water is moved, treated, stored, and distributed. The adage, water, don't waste it, is frequently thrown around as a slang. However, the application of this practice of not wasting water and appreciating the constant supply privileged to us here needs to be emphasized. As it stands, the CWSA supplies fresh water daily to 43,071 customers, and that is quite a task. Join us as we take you through the process of providing water from source to consumer.
Jennings water system, where we are here, now being in operation for about 9-10 years. The system, the first stage where we collect the raw water, that's in the dam, where we dam the river, slow up the speed of the river, the water flowing, have it a bit quiet. We collect some on the side in what we call a chamber, and then it flows into the sedimentation tank. And then it goes on to the slow sand filter. And from then, it is being stored in our storage tank, which have the capacity is 500,000 gallons. And then chlorination to the last stage of the treatment, and then it's being distributed. The distribution system consists of 26 miles of pipe of different and varying sizes, 12-inch, 10-inch, 8-inch, and 6-inch. The distribution point starts at Byra. There on traveling south is being supplied right along the Windward Highway. And this water supply residents as far down as Diamond, with the ability and the potential that it can continue into Rothermill and the Calico region. This is one of the sources that was affected terribly in the flash flood of April 2011. It was real challenging to get this system restored. Because of our island, the mountainous terrain, it's very difficult to get pipes that were damaged or washed of the flood to get them back into place for the restoration of the system. With some effort and determination, it was done. And the system is right now is back to normal. We had the perimeter fence that's all damaged. That has been replaced. All the lines have been restored. Our dams and our filters were clean and restored back to normal. Where we are here at our storage tank, we are at an elevation about 868 feet above sea level. So that gave us much a leeway at the lower ends that residents who are living on the high areas in the village are able to supply water to them, knowing that all of our systems in our country in St. Vincent is being gravity fed. We do not employ any use of any mechanical device like pumps or such like. We depend on the gravity. We collect the water at the high end, right as high as possible can in the mountain. And most of our residents, most of our people are living in lower ends, so that gives us a plus in our supply. When this was implemented about 10 years ago, it is a result of the trust that the CWSA has in terms of improving the water supply to all of its residents. And this system has helped tremendously in the last 3 and 4 years when we had the dry weather spell. The system was the one that we mainly depend on to take water to the resident. And because of the network of all our systems, we were able to transport water from this system into other areas where other systems supplies. We have total about 11 water systems. Our average storage capacity is about 4.4 million. From the CWSA point of view, continue to look at ways and means, and we're always looking for areas where we can improve our systems and to have a better quality and also a quantity supply of water to our users.
The water distribution process at the Jennings system is extensive, yes, but as was mentioned, they are not all as complex as this. The Jennings and Dalloway systems are the only ones with a distribution process of this magnitude, with the smaller systems being different. Our mandate at the CWSA is to ensure that there is a constant supply of water to all consumers, day or night, a task that can sometimes prove to be very challenging. Some of these challenges can range from the fact that our sources are in the upper regions of the mountains and densely forested areas of the country, transporting and connecting large pipelines in these areas, which is quite an arduous task. One of our most harrowing seasons is the hurricane season, where we are always on high alert for natural disasters and the havoc they bring with them. The flash flood of 2011 severely damaged two of our systems. They were the Perseverance and Jennings systems. Let us take a look back at those damages and where we are today in terms of repair.
Mr. Victory, we are on our way to the Perseverance system, water system. Tell us what we're seeing here.
What is here, where the river is running here now, was solid was land. This area was land, solid land. Approaching to the bridge that is over there. And we had our lines suspended across, spanning the river there, about 80 feet, spanning the river and come across over to the solid land. But because the river has changed its route, and it's taking this portion of the land, it removed the lines from across, from the solid area, and it's all down about 140 feet of pipe now is exposed. We will have to build scaffolding and to get our lines back in. It will take us a while before we can reconstruct this part of it. And this is not the only place that is like this. We have areas worse than this and as like this also. We have to fit totally new lines, new pipe in this area here now. Okay. The challenge is to get them to this spot here.
Yeah.
That's a challenge.
Because
we have to do it all with manual labor. The vehicles cannot come to this point at this time. So we have to physically lift them and get them up here.
And that's again because the road has been destroyed because the river changed its course
and damaged the road and the bridges, so we cannot have access by vehicle to get our materials, pipe and fittings into this area here. This is what we call the intake or the dam. If you note, we have a wall that is across the river. That's the dam wall. And this is where we tar the water a bit and it's backed up here and get it into our grit chamber, which is at the side here, and then get it down to our customers.
Okay, so we are at the top of the Perseverance system.
Right where we started now.
Okay.
So the guys we are seeing is more of the temporary guys that we employ to assist us to get the job executed as fast as we can. And we need to get that dam, the dam clear. The dam was totally full, filled with debris and big stone as you see here. Yeah. So they are removing the stone now that we can get the depth of water there, that we can get it into the clear well to get it down. Okay. Have you noticed below? Here, all the stone that have been removed from above the dam and have been thrown over the side here.
So how much of this area you have to clear away?
Well, just at the back of the guys, there, right back to all of that area we need to excavate to get the depth, the water depth back there.
And right behind me here, I'm seeing some work.
Well, this is where we want the water from the dam to get into this chamber here. This is called the grit chamber.
Right.
And this chamber also, the covers that were there, they float away, they were removed, and it is all filled with sand.
Yes,
so we got to clean and get it entirely clean out.
Since the flood, the CWSA has been very busy with the rehabilitation of the Jennings and Perseverance systems, undertaking reforestation with the Forestry Department, reconstruction of the damaged areas, and most importantly, repairing and replacing damaged pipelines. As Ray mentioned before, there are a total of 11 water systems across St. Vincent with a combined storage capacity of 4.4 million gallons. The Jennings, Majorca, and Dalloway supply systems are the largest with the storage capacities of 500,000 gallons each, but the Dalloway system has the potential for the storage of up to 750,000 gallons of water. To eliminate the instances of persons receiving an unsteady supply of water, the CWSA is constantly engaged in major upgrades to several of our sources, including Fancy, Majorca, and Montreal. There was also the introduction of 3 new sources at Airy Hill, Mamoon, and Acres. Here is a look at the work that we have completed thus far. The Layou Water Supply Improvement. This project, completed in 2009, increased storage to 150,000 gallons and improved the supply to consumers on this network in Layou and Bookament. The Layou Bookament Extension. A further improvement to the 2009 work done, this was done in 2011 in the form of additional pipelines and road repairs. The Dalloway to Bookament Bay Improvement. This project was implemented to improve the distribution to the residents in the Bookament Bay area and also ensure a constant supply, with the construction of the Bookament Bay Resort, which would create more demand from this system. The Mamoon System Development, Phase 1. The new Mamoon System Development was created in 2009 to improve the quality and supply of water to Upper Lago Heights and Green Hill residents. The Majorca System Improvement, Phases 1 and 2. Phases 1 and 2 of this project were aimed towards the increase of the Majorca storage tank by 500,000 gallons and the improvement of the water supply and quality, which became an issue after heavy rainfall. The Montreal to Acres Improvement. This project was commenced to improve the distribution system from Montreal to provide, for the first time, a steady 24-hour water supply to the residents of Acres. The Perseverance Water Supply Improvement. This assignment was geared towards increasing the storage capacity of the catchment system by 250,000 gallons and also improve the water quality, which suffered after heavy rains. The Georgetown to Toroma Extension. This mission was undertaken to extend the Perseverance supply across the Rabica Dry River Bridge to a new housing settlement. The Fancy Water Supply Improvement. This improvement was commissioned to introduce the first storage tank in Fancy and improve the water quality supplied after heavy rainfall. The Airy Hill Jack Hill Improvement. This project was employed to provide a first-time supply to the residents at Airy Hill and also improve the supply in the Belmont area. The tank has a storage capacity of 12,000 gallons and was commissioned in 2010. The Water Resource Management Unit is a recent addition to the CWSA, responsible for the management of the water resources, monitoring of all climate data which includes rainfall, evaporation, solar radiation, temperature, pressure, etc., river flows, and GIS mapping, just to name a few. The CWSA has also taken steps to improve the water supply to residents of North Leeward. Bernard Maloney, engineer, is in charge of this project and he will tell us more.
My name is Bernard Maloney. I'm the construction and projects engineer at the Central Water and Sewerage Authority. Right now we are on site here at Rose Hall in an area called Jack Hill, where we will be constructing our newest storage tank. The present condition with this system is that after periods of heavy rainfall, the turbidity level rises and our system automatically shuts down. So what we're trying to do is boost our system, boost the storage capacity of our system by building 2 tanks, one here at Rose Hall and the other at Belle Isle. So the first phase of the project, where we are right here on site, we'll be constructing a 250,000 gallon storage tank, reinforced concrete, right here on this site. But before we can actually get to this site, we have to do some road works. We'll be stabilizing the portion of road coming in. We'll also be constructing a 130-foot cantilever retaining wall to get to the site. And well, that basically encompasses the first phase of the project. We also have some pipe work that is actually going on now as well.
One of the biggest technological steps the CWSA recently introduced was the Remote Monitoring and Management System called SCADA, which was implemented to facilitate the monitoring, operation, and management of all the major water systems. The CWSA always strives to go above and beyond to show its appreciation for customers, and in 2009, a water tender was purchased to facilitate the distribution of water during emergencies, disasters, and periodic outages. So far, since its purchase, the water tender has been used in the 2009 to 2010 drought, after the wake of Hurricane Thomas, following the April 2011 flash flood, and various other instances of sudden and prolonged water disruption. To ensure a continuous and safe supply of water to our consumers, the CWSA's in-house laboratory technicians perform various tests on water samples collected daily from all water sources across the island. Jonathan Abraham, lab technician, elaborates.
Remove the filter paper, put it in the funnel, and then pour over 100 mils. Turn on the button, pump. All the water is finished filtered through. You turn off the vacuum pump, open your petri dish, and take off the filter paper. Put it in your petri dish. Cover. This will be incubated for 24 hours. What's going to go up on this sample, if there's any, will be coliform. That's bacteria of any type. The test we're going to do now is for iron. So I'm selecting the method. First of all, you rinse your bottle with distilled water. Take the sample and pour in 25 mils. Take the reagent, which is the iron reagent, pour it into the sample, store, rest, and then you press shift timer, which will allow this to cycle for 3 minutes. Okay, I'm going to use this distilled water after the 3 minutes to standardize the machine to 0. You fill it the same way up to 25 mils. Right, and then when the 3 minutes is finished, we're going to standardize the machine to 0. Alright, you take the distilled water, the one with the distilled water, and then wipe the bottle properly so that your fingers will leave no print on top of it. And you put it inside here, cover it back, and press 0. Wait until it's 0 up. Right. You take the sample now, clean it the same way. Make sure your finger does not touch. Remove this one and you put in the sample. Alright. And then press read enter. weight. And the reading is 0.02 milligram per liter. That's the amount of iron in the sample, which is way below the amount of iron should be in a sample.
The most recent accomplishment of the CWSA was the design and construction of the New Montrose Technical Operations Complex, which was built to provide offices for the technical staff of the CWSA and Solid Waste Management Unit. As you have seen, the process of providing drinkable water for you, our consumers, is not an easy task. From locating the sources to supplying the water straight to your tap. Thanks for joining us, and we hope that from today, the phrase, "water, don't waste it," takes on new meaning for you.